Alright, so let's start with this new topic, which we call partial fractions. Partial fractions. So this is one of the concepts that is important in mathematics and really dwells in the field of algebra, and is the part of mathematics where your algebra is really going to shine. And what does it deal with? Let's say we have a fraction like this. Let's just take this as an example of it, something that is pretty much easy, that we know how to do very well. Imagine if this question says simplify 3 over x plus 1 plus 4 over x plus 5. Now, we have a case of two algebraic fractions. And these two algebraic fractions, what do they want us to do? They want us to sum it up. I mean, this is pretty much quite easy, right? And that is what we're going to have what LCM to be x plus 1, x plus 5. Now, x plus 1, x plus 5 divided by x plus 1, we have x plus 5, then multiplied by 3, we will have it to be 3, open bracket, x plus 5, plus, what do we have next? We have it to be 4, open bracket, x plus 1. Then we have this to be 3x plus 15 plus 4x plus 4 over x plus 1, x plus 5. So that gives us 7x plus 19 over x plus 1, x plus 5. And that becomes the answer to the problem. So this is the solution of our work. That's it. So when we had this, we have the addition of two different fractions, 3 over x plus 1 plus 4 over x plus 5, add up to this particular single fraction that we have here. So we pretty much know this already. This is when we just add two fractions to get a single one. The problem of partial fractions means we are trying to reverse this entire step. We are trying to reverse the step. So how do we go from having a single fraction like this and splitting it into its two or more partial fractions it came from? That's what this problem of this topic is talking about. How do we go from taking this 7x plus 19 over x plus 1, x plus 5 into these two fractions that it came from? That's the problem of partial fractions, like I said. So, and in order for you to work with partial fractions, you need to understand that we have different types of partial fractions, and the different types of partial fractions just come through the way that our denominator may appear. So of course, we're going to write down the list of the types of partial fractions that we have, and then we're going to take out to solve them one after the other. So let's just go with it now. Types of partial fractions. Alright, so just like I just tried to say in a second earlier, in the field of partial fractions, your denominator pays a higher importance, because it is your denominator that will determine how you are going to solve the problem. In partial fractions, the main target is that they'll give you a single fraction like this, and they'll ask you to resolve it back to the two different forms or the three or more fractions that initially came from. That's to resolve this into its partial fractions. So you could say that this and this are the partial fractions of this. So that's just the target, like I said. So we have different kind of partial fractions that we have. So it depends on the way the formula of our denominator, the form our denominator is going to appear from. And let's take it to number 1. So the first one says, so the first kind is called the those with non-repeated linear factors as denominators. So in this particular case now, at the denominators, so in this particular case, we have a case where we have linear denominators. When we say an equation is linear, it means that the highest power of the unknown is 1. So like this particular case will be left here. So let me leave the example here so that whenever you see something like that, we have it. So 7x plus 19 over x plus 1 x plus 5. So that's the easiest case of partial fractions, which we call the type 1. So now the second one is those with factorizable non-linear denominators. So in this case, we're having a case where we could have the denominators to be maybe like a quadratic expression. It's no longer linear, but it is factorizable. So in the case of something like this, 7x plus 19 over, let's say, x squared plus 5x plus 6. So the reality is that this your type 1 and your type 2 are very similar, because this your x squared 5x plus 6 is just a quadratic expression which we can factorize to something like this. So that means your type 1 and your type 2 are very, very similar, and you can see the main difference is just the way your denominator looks. So as much as possible, I will try not to change the numerator so that you start getting the point that the denominator is the most important part of the partial fractions in trying to how we restart the solution process. So number 3 is those with non-factorizable non-linear denominators. So an example of this could be 7x plus 19, and then we have like a quadratic equation which you know cannot be solved with the factorization process. That is, it is not factorizable. Something like x squared plus 1. Now this could be a type 3 partial fractions because the denominator is not factorizable, which means our process of solving will be different from this type 1 and the type 2. Do you get that? So once you are starting, you have to first of all know the kind of partial fractions you are dealing with. So let's take the fourth one. We could also have a case where we have a repeated, those with repeating denominators. So let's say we have an example like this. This is the example of how this comes in place. Let's say we have 7x plus 19 over x plus 3 squared. So when we have something like this, we have it to be a repeating denominators, x plus 3 squared, meaning that the denominator is repeating like that. So it will have x plus 3 or x plus 3 like that. So that's how it works. So again, let's go over the 4 types that we've written so far. The ones with repeating non-repeated linear factors. So you can see these ones do not repeat, they are different, right? So these are the linear factors that we have here, because the highest power of unknown is 1. There's no 2, there's no 3 there in the x. So we also have factorizable non-linear denominators, and we told you that this here type 2 is very similar to type 1, because when you factorize the denominator, it becomes something like this as well. Then the number 3 says non-factorizable non-linear denominators. So in this case, we can't factorize the denominators, and number 4, you have repeating denominators. Then the 5th one, I suppose, are what we call improper fractions. So improper fractions. So in the normal case of an improper fraction, aside from in this topic of partial fractions, we could say something like 3 over 2 is an improper fraction because the numerator is bigger than the denominator. In a similar vein, now for partial fractions, we have an improper fraction when the highest power of the numerator is bigger than the highest power of the denominator. In the case of, let's say we have this one and we flip it, say where we say x squared plus 5x plus 6 over 7x plus 19. So we have something like this: x squared plus 5x plus 6 over 7x plus 19. So if you look at the numerator, the highest power of the unknown is 2, and the denominator, the highest power of the unknown is 1. When we have something like this, we have an improper fraction. So those are the 5 different kinds of partial fraction problems that we have. So let's go over them again. So we have non-repeated linear denominator, factorizable nonlinear denominator, non-factorizable nonlinear denominator, repeating denominators, and we also have what the improper fractions. So now it's not very important you know all these different kinds of partial fractions or to store it in your head as if it is anything per se. It's just for you to know that we have different examples of them, and where we are going to solve them depend on which type it is. And don't worry, you'll get used to everything. But again, let me just drive the point home again. This first example I did was to add up 2 different fractions that we have, algebraic fractions, which is a step that we are very familiar with. We've been doing this all over and over again. But when it comes to the problem of partial fractions, they twist the problem around. They'll give you a single fraction, which could be the end result of this particular process, and they will tell you to get the 2 different fractions where it came from. And those 2 different fractions it came from are called the partial fractions. And the process of reversing is usually called a resolution. They will say you should resolve something into the partial fractions. So yeah, that's the point about this topic, and it's really going to be very interesting. So without taking too much time, let's quickly jump into it.